Okay, so we started this session looking at so many things. I remember we started with electrochemistry, and then we went on and on and on. I remember we joined the grade 11 class as well, right? We were doing electrostatics and all of that. Oh yeah, we did some work energy and power question, lovely. So today, I got this question yesterday from Leslie, and I thought, okay, let's start from here. I'm going to try to run so that I can cover as many concepts as possible. Okay, so our first session would end at 6, so we can also change lights. Yeah, this question got me yesterday because, yeah, if I ask you right now, everybody thinks this object is moving just like me and Faima. We thought this object is moving this way. But it's a lie. This object is actually going this way. And I see Butler's face is surprised because you thought it was going this way. You sure? Oh, you read. Ouch. Okay. At least someone listened to me that we should always read. Before I met Butler, she would have started from here. But now she knows that she has to go up and read. Okay, let's read. A block is released from rest at point A and slides down a curved frictionless. Remember what we said. This is now frictionless. Make notes for yourself. Frictionless. If it's frictionless, is anything pushing the object? No, there's no applied force. So we're saying no friction, no applied, and there is no tension. So no fat. Which means it is an isolated system. Because there is no friction, there is no applied, and there is no tension. Okay, now I'm not sure. It's a juggle. It's a jungle here of papers. I don't know where she got this from. So I don't know. Okay, it came from a friend who came to Elena. It came to a teacher. Came to the class. Yeah, a friend to Elena. Elena to a teacher back to class. So it's traveled a few phones. We're not sure. Okay. Guys, quickly, we are seeing that there is no there is no external force. So it is an isolated system. All right, it moves along a frictionless track, BC, and finally gets up a rough. The word rough simply tells us there is what? Friction. Inclined CD. The coefficient of kinetic friction is 0.35. This takes us back to Newton's laws, where you've got to have your normal force well-defined. Your normal force must be well-defined. Otherwise, remember the whole story. Once your free body diagram is wrong, forget about it. Okay. Stating what's the principle of conservation of mechanical. I'm sure 2 weeks ago we had this conversation of mechanical stuff. That we said in an isolated system, that's what's key. What is conserved now? Mechanical energy is conserved. Please remember that every law of physics that has conservation has to do with what? Isolated. Is that okay? So what's the law? In an isolated system, the total mechanical energy is conserved. And you get your 2 marks quickly. We don't even waste time. In an isolated system, the total mechanical energy is conserved. Those are laws that you should be rejoicing when you see them. All the conservation, I almost said all the conversation laws. All the conservation laws. Make sure you put the word what? Isolated. And whatever you are trying to define is conserved. What is the law of conservation of linear momentum? In an isolated system, the total linear momentum is conserved. Okay. Now, use principle of conservation of mechanical energy. Ladies and gentlemen, I want to show you something very important here. When we say conservation of mechanical, we said it's conserved. It means top and bottom are equal, before and after are equal. And I mentioned something last week when we were doing physics, that there is a particular formula that works all the time. It fulfills all conditions. If I ask you to write down the conservation of mechanical energy, some of you have forgotten. All right, it is EMEC. I want to show you something quickly. Okay, check here. The examiner says to calculate the speed of the block at point B. So where are we working at? We're working at A and B. Network. But because mechanical energy is conserved, we are saying that the mechanical energy at point A is the same as the mechanical energy at point B. Let me just check. I might have lost these guys at home. Yeah. All right. Guess they'll catch up. Let me check something quickly. Let me try the other one. Maybe it should work. Just a second, guys. But this looks better. All right, write down for me quickly, everybody, the formula for work done by non-conservative. Let's write down that formula. If you have your formula page, work done by non-conservative force. Please, let's write that down quickly. Work done by non-conservative. Work done by non-conservative. All right, this is completely now out. All right, so we're looking at work done by non-conservative, which means the kinetic energy at point A is the same as the kinetic energy at what? Point B. And I said there's something I you here. E mech at point A is equal to what? E mech at point B. Now, what is mechanical energy? That's the key. If you forget that, it becomes a problem. Let's quickly define mechanical energy. It is what? Sum of kinetic and what? Potential. Are you aware that if I just use the work done by non-conservative, it actually tells me everything? What is the work done by non-conservative? Change in what? EK plus. Can you say this in words? It is the sum of which two energies? Kinetic and, which is what I have here. By using your formula page and playing smart with your formula page. Are you aware that both of them are the same? So it's the same. You are allowed to use any of the two. I would use both. But I'm just trying to show that should you forget in an exam what that formula is, that's your safe haven over there. Work done by none. Because I can prove. Check this. What is this? Since it's an isolated system, let's quickly work. I once saw a question like this. What is this? 0. This is change in kinetic energy simply means final kinetic minus what? Initial kinetic. All right? Plus final potential minus initial what? Potential. Can we move all the initials to the left-hand side? What am I going to have? Initial kinetic energy plus initial what? I don't know if what I'm doing makes sense. The two negatives. What do I have here? Final plus what? Please, what do you see here? It is the sum of kinetic and potential. And what is that? That's mechanical. So what are we saying? Mechanical energy initial is equal to what? Mechanical energy final. So in an exam, should you forget that law, use that. It's the same thing. Mechanical energy at point A is equal to mechanical energy at point B. What is mechanical energy? Sum of kinetic. So can we break this down to say sum of kinetic energy at A plus what? Potential energy at A equals to kinetic energy at B plus what? Potential energy. Please remember once you remember the main formulas, life becomes a lot easy. What is the formula for kinetic energy? Half mv squared. At where? At A. What is potential energy? mgh at which point? At A. So know your formulas. That's all for physics. What do you have? Equals to half mv at B plus mgh at B. Now, if I look at this whole thing here, we can start substituting. Please listen. Do you notice they did not give you mass? When you get a question like this where there's no mass, guys, you are allowed to do that. Okay? Don't let me do that. Let's do what's right. What is right? Okay. It's to say m is out. Factorize. 1 over 2 VA squared. But that's also correct. Plus GH. I factorized m, right? Because I don't have it. Equals to m 1 over 2 VB squared plus. Now, if I tell you to divide both sides by m, what happens? That's what I did earlier on. Now, can we substitute, guys? Please, I want you to learn this formula. Even if you know how to substitute, if you don't know the formula, you're still going, where are you going to substitute? So please, up to this point, it is very important. Mechanical energy at A is equal to mechanical energy at point B. Once you get that, that's how work energy becomes very simple. So please practice this formula over and over again until we know it. Let's go back. Object started at what? A. And it started from rest. What's the velocity at A? 0. Okay, let's work together. Half 0 squared plus 9,8. What is the height at A? Check the diagram. It's 5. That's why I'm using letters for us to be able to see. Times 5 equals to 1 over 2. This is what we are looking for. Plus, look at the diagram, guys. What is the height at B? It's 0. It's on the ground now, right? The lowest point. 0. So we're done. I don't know if you see. This is 0. This will give you 49. 1 over 2. What do? Divide both sides by half or cross multiply, whichever one you want to do. VB will be equal to what? 98. We look for the square root of both sides. What's your answer? Give me 9,899. So it's 90. 2 decimal places. It's 899. 2 decimal places means 90. Round off to 2 decimal places once you are done with your answer. You are allowed to round off there, 9,90. It's actually on the instruction page. Round off all answers to 2 decimal places. That's why you should read the instruction, which you never... Have you ever read that thing in front? You must be bored, eh? To have read. So you read the whole thing. Okay, it's okay. But don't read it for more than 1 minute. The remaining 9 minutes, multiple choice. You start quickly. Multiple choice. I need to find a session where we just answer multiple choice. Just multiple choice. They really test your content, whether you know your story. Yeah, they all, in most cases, 2 are wrong. Yeah. If you know your content a little bit, you can guess right. Oh, I know you want me to teach you how to guess right. But it requires a bit of content because out of the 4, 2 are completely wrong. So first thing is to eliminate the first 2 that are wrong. Now your probability of getting it right is 50%. Okay, what if the answer is A and... One for trial. Sure. All right, you can write a petition we can all sign for the department. Okay. So guys, we are done with that, right? And you know why we used, because the examiner was specific saying use the principle of what? Conservation of mechanical energy. Now look at the next one. Use again energy principles. Once you see that, stick to that same formula. It works 100% all the time. Which formula? WNC. But what are we looking for? The maximum height reached. Let's start by writing our formula. What's our formula? Work done by non-conservative equals to what? Change in EK plus change in what? Can we expand this formula? What is this? 1 over 2 m Vf squared minus Vi squared plus mg H final minus what? Please, that is important. Your ability to be able to expand that formula is very key. And by now, everyone should know. You have written this formula over and over again. So every time we get to work energy, let's try to stick to this. It just always works. Because sometimes I'm afraid of your free body diagram and the mg sign story. But we need to know that as well, though. Maybe I can do that after this. But now, we are considering what? Let's quickly check. Where are we considering? Sorry, I know you were writing. Height H. Where is H? It is between C and D. What non-conservative force is working here? There is a non-conservative. What is our non-conservative force? We said friction, applied, and tension. Which one do we have here? It's friction. How do we know there's friction? They said it's a rough what? Surface. The object is not being pushed. The object is not being pulled, so there's no applied. There's only one object. If there were two objects and a rope, we will say there is what? Tension. So this is just what? Friction. So when I come back here to my formula, I already know that the only force, non-conservative force here is what? Friction. So can I write my formula as friction, delta x, cos what? Theta. We know the formula for work as W equals to F delta X equals theta, right? All right. The question now is, guys, we're just going to substitute. But for friction, what is theta? 180. Always. Don't say whether it can be 0. No. It is 180 all the time. Let's go back to our question. Do we know friction? Let's go back. Do we know friction? Okay, Bibi, what's your friction? We don't know friction. What we know is what? The coefficient of kinetic. Now, please be careful here. In order for you to remember what to do, a quick free body diagram would just be nice. And I don't need to draw it separately. I can just draw it on the object, right? What is my free body diagram going to look like? What is that? Normal force. What is that? G. How is the object moving? Up. So where's friction? Down the plane. But there is a problem here. We don't even need the mass. The problem we have is our free body diagram is not workable easily. Because we don't know normal. What is the formula for friction? Let's go back to our empty page. So let's quickly deal with friction, everybody. Friction, it's there on your formula page. Mu K normal. But I have this, my diagram looks like this. All right, guys, if I were to draw FG, and friction is also that way. That is normal. I don't know if we are all okay with this free body diagram. Biggie? Are we okay with this free body diagram? Fahima? You kind of look lost. You sure? What is the formula for mg parallel? Mg sine. I like using alpha, not theta. It confuses learners. Mg cos alpha. Because Elena writes theta and still comes here to write theta. And they are different. Don't forget this. I once mentioned that, guys, when you get your paper, on the front cover, let me show you a paper. Let's get a paper. Because I want you to see what I'm going to do. Let let's see, because I saw this thing back now. All right. Just get a random physics paper. No, not profile. Come on. A random physics paper. I want you to remember what I'm going to tell you right now. Any paper, just any. Please keep this at the back of your mind. So that's your paper. So when they give you that paper, quickly see that the examiner is reminding you of gravity here. FG parallel. P for parallel. S for sine. I would not forget. Just use parallel and sine. Don't create problems. Parallel. Forget perpendicular. Parallel and sine. Okay? Hello? I know the word P perpendicular is also P. But just think of, you are looking at parallel lines. Okay? I know, Tesmia, sometimes you just want to prove that you are stubborn. Okay, let's do this. I'll look for another system for you. Check this. Draw a line on P. How is that line to S? Parallel. So we are done. So we are done. So this line and this line are what? Parallel. So we're okay. Parallel and what? Sine. Make sense? So that's just the way. When you get your paper, let everything speak to you. So that I know that my parallel is sine. Therefore, my perpendicular becomes what? Is that okay? All right. And if you want to try again, something just came to my head. How do you write a C? A block C. 90 degrees. That's cos. Perpendicular is cos. So many ways. That's just the... I don't remember. Anyway, so what is my normal force, guys? My normal force is what? mg cos alpha. Why? Vertical forces will be what? At equilibrium. So I know my normal force. What? So what is frictional force now? It is mu k from the formula. But what is normal? mg cos alpha. I could get my m, but I want to work without calculating m. Just so you're not so shocked that they didn't give you m and we didn't use it throughout. Do you know I could get m from here? I know the velocity there at point B, which represents my kinetic what? Energy. So I know, will I get it? Yeah. I could get it from here. And this one is simply mechanical energy. And I know my velocity. But I want to work without getting m. Yeah, you can substitute VB anywhere here, you get m. But I want to work so that in case you're not given m, don't say the question is wrong. Something is missing. No, this paper was last year's paper. Funny excuses. No, they didn't like us. They were supposed to set a COVID paper. We don't care. Whether we know m or not, we use our algebra. Let me see if I can get these guys back, because I kind of saw that. Anybody give me the code? Quickly check your phone for me. Please check your phones. I need that code. Let's see if we can get someone still sitting by the phone praying for network. Anybody? Somebody? Yeah, that one with hyphens. QEW. Don't worry about it. Yeah, continue. VXD. VZD. Okay, thank you, Vicky. VZ DX NPE. Let's see. Now it's still slow. They'll watch it later. All right. We'll just do 2 questions for now. Okay. So, are we okay, everybody? So far? We said we want to work without calculating what? The mass. Just in case there's no way to calculate. I want to give you confidence that you should just continue. Now, what is my coefficient? 0.35? Yeah. Do we know mass? No. 9.8 cos. What is that angle there? That alpha is the angle here, which is what? 30 degrees. So we want to work without m, and there's no problem with that. Please multiply 5 times 9.8 cos 30 for me. 2, have you rounded off there? 9704. Okay, let's at least 4. 9704 m. Don't forget your m, because we don't know what m is. It's a variable. And I don't want to calculate it. Are we okay? Elvic? Okay. I forgot what? No? It's not minus. Sorry? No? I need to calculate my friction first. And yeah, you can, because there's a mark for that. There's a mark for this. And there's a mark for that substitution. What they will not do is they will not give you that mark there, because you're using that answer back in here. So there's another mark for that. That's already 3 marks. So now, do I know my friction? We do. Which is what? 22, okay guys, I need space. I don't want to squeeze my work there. So let me do this. Okay, I'm just going to remove this now. Are we okay? All right. What's my friction now? Guys, trust the process. Just keep substituting. What is friction? 2,9704 m. What is our delta x? Let's go check. Guys, do we know delta x? No, we don't. That's your delta x. Sorry? V final is 0. 9.91. The velocity here is the same as the velocity there. Why? Because it's an isolated system. That was actually an exam question. So the mechanical energy here is the mechanical energy here. It's an isolated system. No, they'll tell you. Well, they did. They did. Check. It's because you didn't read through. Let's go back. A block is released from rest at point A and slides down a curved frictionless track AB and then moves along a frictionless horizontal track BC. They told us. No, but it's frictionless. When it's frictionless, that's what I do. There is no applied. There is no tension. It is isolated. This one now talks about it finally moves up a rough. The word rough simply tells you there is what? Friction. So take note. I once saw an exam question where they said, what is the velocity at C and why? The velocity at B is the same as the velocity at C because it is an isolated what? System. No energy is lost. It is an isolated system. No energy is what? Lost. Make sense? All right. No energy is lost. Okay, where were we? Trying to find delta x. Do you notice that it's a right angle triangle? I have h, I have delta x, and I have what? 30. What is sine 30? Sine 30 is opposite over hypotenuse. And what is sine 30? Half. Equals to h over. Let me write it on that page so that it's clear. Should you be looking at this solution again? All right. So we're going to get what? Delta x. And we know that what? Sine 30 is h over what? Delta x. 1 over 2 equals to h over. Can we cross multiply? What is delta x? 2h. Show that calculation too. Show all your calculations. You don't know what the examiner is looking for, so just show everything. All right, can we move on? So, 2h. We spoke about that theta there for friction. What did we say? 180. All the cos 180. Okay, now, let's do this together. 1 over 2. Do we know the mass? No. Do we know it's at the top? 0 squared. 9 0 squared. Plus, do we know mass? No. Do we know G? Do we know the final height? Okay, let's check. Where's the 5? But we're not there. We're working at CD. All right? So my final height is H. My 0. Because it started, moved up. So height H minus what? 0. Guys, do you notice my M cancels again? Because if I were to cancel the M, we can continue working. It doesn't matter. Let's continue working. Beautiful. It's 2 times 2, 9. Oh, da 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 da. Give me 8. This would give me 0. This would give me 4. And that would give me 1. 2 times 9, 18, 19. Why 5? 2 times 2, 4. Sorry. 5. 180 is what? Negative 1. Which makes all of this what? Negative. And I have what? HM. Guys, just do the right maths. Physics will fall into place. Do you want to give me that answer? Half 0 squared minus what? Somebody's giving me negative. Somebody's giving me positive. Negative. Comma 0. Now there's M, right? Okay, what's next on the other side? 9,8 what? You said we should continue working without. Okay, since we are looking for height, can we move everything that has height to one side? This value is going to come there, right? Let's continue with the M. Don't let's be. No, let's just continue with the M. Huh? We should get it out. It's toxic. No, let's just it doesn't disturb us, right? But I would have removed it from the first. It's fine. It's okay. No, I don't want to. 9,8 mH equals to what? Negative 49005 what? It's still there, M. It's making you mad because it's M. Do you notice these are like terms? Okay, what do we have? Negative 15, 74009. Okay. Now you. Let's just ignore Mosam. Okay, is this fine? All right. And we have MH, right? Equals to what? Negative 4900. What are you looking for? We are looking for h, right? So what do? We divide everything by negative 17, da 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 da. Right? What's wrong? 49,005 m divided by negative 15,74. Do you see what the m did now at the end of the day? All right. So don't. It's 0 squared minus 9, what's our answer? 3, wrong. Meters. Thank you. Now it's correct. Guys, the main thing is just the formula. That's all. It's the same thing. But guys, whichever way, just know the formula. That's the main thing. All right? Let's know the formula. So, I want to do something for some of us that might be struggling with the formula. I want us to write the formula afresh. Okay? We're done with the question already? Yes, precious. Okay. Please and please, I want to just go back to the first. The what? Meters. No, not this one. This one is gone. You think I still have the M there? No. But you know now that in an exam you could have gotten rid of that M long ago if you want to. And it shouldn't. So when you don't have the maths, don't feel there's something incomplete. Just keep working and trust the maths. Okay? Trust the process. All right. I'm done with this, but just want us to rewrite the formula. Work by what? Negative equals to what? Change in kinetic plus what? Change in, let's do this together. What are the non-conservative forces? Work done by friction plus work done by applied plus work done by what? You just check whichever one is there in the question. You don't have to write the whole thing. Whichever one is there, that's the one we use. My worry is on the side. Half, somebody could write it like this. Make sure you choose one that you would remember, please. And the squares are inside. Plus, it's wrong. Please, this is wrong. Let's do it, baby. This is wrong. Why? Do you know why it's wrong mathematically? Look up, baby. You're asking if it's wrong. Look, let's do simple maths. What is 7 squared minus 2 squared? This is 49 minus 4. What would this give you? 45. But if I do 7 minus 2 squared, what is this? 25. Why? This one is difference of 2 squares. This one is foiling. So let's be careful with the formula. Or, like Mosam is saying, you could write this as VF squared minus 1 over 2 VI squared plus MGH final minus. All right, so please practice the formulas. Choose whichever one works for you, but make sure you do the right thing. And look at the one I cancelled. Please, let's make sure this is cancelled. Don't put the squared outside. It's wrong. The squared should not be outside. The squared should be inside. VF squared and VI squared. Guys, this is how work can be done cheaply, easily. You move on. Free body diagram, know your forces, and then you are done. Can we go for the next question? Sorry? We okay? All right. Let's see. Let's see something we can easily do. I don't want people to. I'd love everyone to do this Doppler effect with the wave. So let's wait for the next when we get back online. I have some chemistry here. I'd love everyone to do chemistry. Well, I'm looking for something we can quickly get done. Electricity here. Okay. Let's quickly get this done. Remember, I don't want people to miss out. Okay, but they watch online, right? So it doesn't make a difference. No. Okay, let's do this quickly. I want us to do these generators. We did generators the last time. All right, so I'm going to do Doppler and let's see, 30 minutes. We could get both done. Let's start from here. 12 marks. 12 marks quickly. All right, the sound wave below are emitted. Please let's read. The sound waves are emitted, which talks about what? The source. By a bird flying in a straight line at constant height. Take the speed of sound as 340 meters per second. All right, so we have a graph here. The first thing I see wrong with the graph is the centimeter thing. How do we convert centimeters to meters? Divide by 100. I know that you always just want to do your own in a different way. It's okay. It makes more sense. It's fine. So divided by what? 100. What do we have? 0.6 meters. Can I ask you something? How many waves are here? Is it 3? You're not. Are you sure? Really? No, guys, look at it again. Is it 3? Cycles. Okay. That is 1. And we have what? 3. All right, hold on. So, it's just colors, you know. Now, if you look at that, and the whole length is 0, how many wavelengths do you have here? What's a wavelength? All right. A wavelength is a distance from one point on the curve to the exact same point. All right, so if I start from here, let's use green. If I start from here, so my graph wavelength is a period. Let's go to trigs. From here to here, that's a period. So that is one wavelength. Yes, that's one wavelength. So how many wavelengths do we have here? 3 wavelengths. So it means 3 wavelengths is equal to 0.6. What is 1 wavelength? First answer is done. So easy. Right? Wavelength. So wavelength is, so somebody else could have measured wavelength. So you could see another question where it looks like this. Actually, I wanted to draw something else. Where's my wavelength here? from the crest to another crest. That's another way of measuring wavelength. From one point to the exact same point on a wave. So wavelength is your period. And grade 10. This is all grade 10. What is frequency? Can we define frequency? Number of something. Number of complete waves that pass through a point in 1 second. It's the same thing. Number of oscillations. Full. Refractions is talking about. No, it doesn't have to do with period. Refractions is your compression and refractions of waves. Where, for example, where you talk about when wave is compressed, when the sound is moving towards. How do you define wavelength? It's the length between two successive points on a wave, or between two successive compressions. You could use that as well. All right. How do we calculate frequency, people? Okay, there are two ways. Okay, I want to look at two ways here. One of them will not be applicable. I want you to take note of your grade 10 for frequency. Frequency is 1 over T. I want us to define all of this. This is frequency, which is measured in what? Let's define it together so that we know. Frequency is the number of waves or number of complete oscillations that passes through a point. That passes through a point in 1 second. But what is T? T is the period, which is time taken for a wave or a complete wave to pass through what? A point. Get the difference. Frequency is the number, right? Period is the time. Frequency, the number of waves that pass through a point. So if I tell you that 3 waves pass through one particular point in 1 second, my frequency is 3. But if I tell you that wave pass, but I'm looking for the time it takes for one complete wave now to pass through a point, that's my period. Period always talks about what? Time. Should you forget, how long is one period at school? I'm already talking about time. Makes sense. So when we talk about period, we talk about what? The time frame. But for how many waves? For one wave. So should you have... The reason this one will not work is that they did not give me time on this graph. If I want to use this formula, my x-axis should have been time. We can get frequency from another formula. There's a formula again that says V equals to F lambda. We have V. No, we use this one in matric too. Yeah, oh yeah. What is V? Velocity of what? Sound. And we are given in this question as what? 340. Do we know the frequency? No. Do we know the wavelength? So what's our frequency? 1,700 hertz. It should be 3 marks. Let me check quickly. How many marks? That's it, 3 marks. So physics, take note of what you have. Use your formula page. Get an answer. Physics is the new LO. It's so easy. Sorry? Yes, that's what I'm saying. Physics is the new LO. Physics is easier than LO. Yeah, because LO is we're expecting LO to be easy, right? Yeah. And we're expecting physics to be difficult. So physics is the new expectation of LO. Because physics is predictable. Yeah, it is. And all you need to do is make a list, write. If you can learn the way to extract formulas all the way. Are we okay? Can we move to the next question? Okay. What's wrong, Elvic? Okay, guys, let's answer now. A detector, mind you, don't forget everything we are doing here has to do with what? Because first line emitted. If okay, I'll show you how to calculate the period. A detector fixed to a pole at the same height at which the bird is flying measures the frequency of the sound emitted by the bird to be 1620. Hold on. I want us to read. It is a detector. This is my listener. Measured the frequency as what? By the way, it's flying. They didn't tell us where it's flying to, whether towards or away. 1620. Let's do something quickly before we start reading. I know some of you already, is the bird flying towards or away? That we can even answer just now. What is the frequency of the source? Frequency of the source is 1000 what? 700 hertz. Frequency of the listener is what? 16? I'm sure we can tell whether it's moving towards or away. Where is it moving? Biggie? Fumani? Towards or away? Away. Precious, do you agree with Piggy? And then he smiles. Precious, do you agree? You're not sure? All right. This is what you look at. Fumani, I want you to focus here quickly. Because this is very important. You see, the away and the towards will affect your formula. Now, look at the source. The source, that's what you look at. The listener, 1620. If this guy moves towards this, the frequency should be higher. But we are getting 1620. It's lower than that of the source, which means it's moving away. They'll ask you and they'll ask you for a reason. What is the reason? The frequency. In fact, let me give you the full. So, it is moving what? Away. Why? We'll start by saying the frequency of the listener is less than the frequency of the what? Source. What is the implication here? Or why is this so? Let's answer the why. The wavelength. All right. Between successive waves, successive wavefronts are increasing. And we know that at constant speed, frequency is inversely proportional to what? Wavelength. At constant speed, frequency is proportional to wavelength. So, as wavelength increases, the number of waves, the number of wavefronts reaching the listener decreases. Reason the listener per unit time decreases. Guys, this is the full detailed explanation of how that happens. Because it's taking longer for the waves to, because they're traveling longer now. The wavelength is increasing. So the number of wavefront reaching the listener per unit time is decreased. And once I say number, it's frequency. So it decreases. And this will greatly affect our formula. Do we know how to select the formula? Plus and minus? Okay. Plus, minus. Calculate. Guys, can we calculate the speed at which the bird is flying? Quickly, let's try. What do you need? Okay, we're looking for the speed, right? All right, let me go back here where we have our information. Please calculate the speed at which the bird is flying. V is 340. Let's use more than 3 minutes here, or 4 maximum. 2 minutes, right? Thank you, Cornelia. Okay, let's go back to the question because I think I might have lost it somewhere. Okay, hold on. Let's go back. I might have lost it somewhere. Too many words. Oh, a detector is fixed. Wait. Hold on. Wait, if the doesn't that affect our away and towards? Let's go back. Wait, hold on. Okay, let's check. Let's just check. A detector. So the listener is what? Stationary. Okay, let's go back. The listener is stationary. Let's go back and check something. The listener is stationary. And the bird is flying. So it's still away. All right. Woo! Okay. Because once we mess that up, there's a problem. Okay, let's do this. Let me help you highlight. We said FL is what? 1620, right? 1620. And VL is stationary. Let's do that. Makes sense. FS is 1700. Looking for VS. And what else do we know? V equals to 340. Please, not more than 4 minutes. Use your formula page. I don't even want to lead you. Formula page. Get me an answer. All right, guys. Let's finish this now. What's our formula? Work with me. Test me here. FL equals to what? V plus or minus VL over V plus or minus VS. Everything multiplied by what? That's what you write first, guys. That's where your 1 mark is. But we said this is moving what? Away. So FL V minus VL over V minus everything multiplied by what? FS. Guys, I wasn't done.
So you needed a special color for this?
Yes, just to make you see that it's different.
Yeah.
Come on. Thank you very much. What is my FL? 1620. 162? I add O. Now, what is our V? 340. What is the listener? That. What do we have? 340 plus VS. Everything multiplied by what? All right. Let's try to make this a bit easy for everyone to do. You know what I like to do? What is 340 minus 0? 340. Confirm? Okay. It means this value here is multiplying that. So what do you have? 1620. What is 340 times? Let me just write it here so that we are all on the same page. 340 plus VS. That's what happens mathematically. Can we then cross multiply? The bird is the source. Okay, let's go back. So fixed to the pole, measures at 1620. So measures talks about the list. The sound waves below are emitted by a bird. The bird is the source. So that's why I said all of this graph represents the source. And we got that frequency as what? 1700. Okay. So it's important. You see, also, if I didn't write it down, I was going to get... This is the detector, listener. That's the bird. Are we together? FL, listener. The bird is the... Okay. All right. What do we do here now? We can cross multiply, right? 340 plus VS. What will this give you? Somebody talk to me. Yep. 578,000. So what is our answer? We take all of that and say minus what? 340. What is your answer? 79 meters per second. All right, are we okay? When we come back from break, before I move to the next topic, I just want to explain red shift and blue shift spectrums, emission and absorption spectrum again. Sometimes learners don't know how to answer red shift and blue shift questions and absorption and emission. Then we can answer all the other questions remaining. Is that okay? All right, catch you on the flip side.